If you watched the two preceding videos, you saw how to solve a system using graphing and then how to solve a system of equations using substitution. Well, here's a third method, known as linear combination. Sometimes it's known as using the addition or subtraction method. Linear combination is very efficient when both equations are written in the same form. And in this case, both equations are written in standard form. And it's very helpful that there's a 3x in one equation and a 3x in the other. Now, some people would just take these two equations and subtract them so that they would end up with a 3x minus 3x. I prefer to always use addition. So the first thing I'm going to do is rewrite the subtract 8y as add negative 8y. Then I'm going to multiply both sides of the equation on the right by negative 1. I call that running a negative 1 through, or just running a negative through. So now everything in that equation is the opposite of what it was previously. Now I take my new rewritten equation and I write it underneath the equation on the left. Then I put a line under it and a plus sign because my choice here is to add these two equations together. And now I will. The opposites, the 3x and the negative 3x, makes 0x. 4y and 8y is 12y, and 12 plus negative 48 is negative 36. So because of the identity property, I now have 12y equals negative 36. I divide both sides by 12, and y is negative 3. Now the second part of this method is the same as the second part of the substitution method. I'm going to substitute. In this case, my value for y, negative 3, for a y in one of the two original equations. So I'm taking the negative 3 and putting it in the equation, negative 3x plus 8y equals negative 48. And now that I've substituted in, I'm going to multiply 8 times negative 3 to get that negative 3x plus negative 24 is negative 48. Add 24 to both sides. Negative 3x is negative 24. Divide both sides by negative 3. X is 8. And so my solution to this system is 8 for x, negative 3 for y. We're very happy about that because we've used this system 3 times, once with graphing, once with substitution, and once with linear combination, and we've gotten the same solution all 3 times. And that's the beauty of mathematics. Here's another problem. It looks a little like one that was in a previous lesson or two, but it's slightly different, although the equation on the left has been used before. And in the previous time we used this equation, we decided to divide both sides by 3. But this time we're going to apply the distributive property to get 6x plus 12y equals 12. And now notice we have a 12y in each equation. So we're going to run that negative through the one on the left and then rewrite it underneath the one on the right. Put the line under it, a plus sign to remind us that we're adding these two equations, and we get negative 2x plus 0y is 36, or just negative 2x is 36. Divide both sides by negative 2, and we now know that x is negative 18. We're going to substitute that negative 18 for x in one of the two original equations. And then we rewrite that down where we have some blank space, and the negative 18 is substituted. We do the arithmetic. 4 times negative 18 is negative 72. And then we add 72 to both sides to get that 12y is 120. Divide both sides by 12, and we get y is 10. So our solution to this system is negative 18 for x and 10 for y. And here's one where they're both in standard form, but we don't have any terms that are opposites or any terms that match. So we're going to multiply one of the equations by negative 2, in this case the one on the left, and by doing that we're going to get the x term for our new rewritten equation is the opposite of the x term on the equation on the right. So now we write that equation underneath the one on the right, put our line under it, the plus sign, so we know we're adding these two equations. We get 0x plus 4y is 24. That means that 4y is 24. We divide by 4, we get y is 6. We're going to take that 6 and substitute it for y in one of the original two equations. Then we're going to bring it down to where we have some blank space. 4 times 6 is 24. Then we add negative 24 to both sides to get that 2x is negative 12. Divide both sides by 2, and x is negative 6. So our solution for this system is x equals negative 6 and y equals 6. Here's another problem. This one's a little more complicated. You cannot multiply either term from one of the equations to make it match or be the opposite of one of the terms in the other equation unless you use a non-integer multiplier. So we're going to treat it the way we would treat fractions. The common denominator for 2 and 3 is 6. So we're going to multiply the equation on the left by 3 and the equation on the right by negative 2. And when we finish, we get 6x plus 9y equals 36 on the left, and negative 6x plus negative 4y equals 14 on the right. And now we choose to write the equation on the right underneath the equation on the left. Draw the line, add the plus sign, and now we add them together. We get 0x plus 5y equals 50. That means that 5y is 50. Divide both sides by 5, and we get that y is 10. And now you probably know what's going to happen next. We're going to substitute the 10 for y in one of the two original equations. And of course, 2 times 10 is 20. And then we're going to add negative 20 to both sides to get that 3x is negative 27. Divide by 3. X is equal to negative 9. Our solution is negative 9, comma, 10. And here's one we've looked at before. And you might remember there's no solution to this system, but we're going to work through it using linear combination to show how we can tell when there's no solution when using the linear combination method. You can see I'm going to divide the one on the left, both sides, by 3. I've done that before if you watched the previous lessons. And now I have 2x plus 4y equals 4. And then I'm going to multiply both sides of that equation by negative 2. Which gives me negative 4x plus negative 8y equals negative 8. And now we put the two together. We draw the line. We're going to add them, but we realize the x terms are opposites and the y terms are also opposites. So we have 0x plus 0y equals 40, or just 0 equals 40. And just like we noticed when we use substitution, we have a false statement. It's not the same false statement that we had when we used substitution, but it's still false. So there's no solution. When two linear equations are written in similar ways, it is often efficient to use linear combination to find the common solution. Transform one or both of the equations so that the terms for one of the variables are opposites. Then add the two equations together and solve the resulting equation for the remaining variable. Substitute that value in either of the original equations to find the value of the other variable.